Recall the definitions of chemical reaction types. Bronsted-Lowry acid-base reactions involve the transfer of protons, H to the power plus, from an acid to a base, with no change in the oxidation states of any elements. Reduction-oxidation, redox, reactions involve the transfer of electrons between chemical species, which is always accompanied by changes in the oxidation numbers of the atoms involved. Assign oxidation numbers to each element on the reactant side. Cu. As a pure element in its standard state, copper has an oxidation number of 0. HNO3. Hydrogen, H, has its standard oxidation number of +1. Oxygen, O, has its standard oxidation number of -2. To find nitrogen, N, in the nitrate ion, number 3 to the power negative oxidation number of N+3, -2, equals -1, therefore N. 6 is equal to -1, therefore N equals +5. Assign oxidation numbers to each element on the product side. Cu, number 3, 2. This ionic compound dissociates into Cu to the power 2+ and number 3 to the power negative ions. The copper ion has a charge of 2+, so the oxidation number of Cu is +2. In the spectator nitrate ions, number 3 to the power negative, N remains at +5 and O remains at -2. Number 2, oxygen, O, has an oxidation number of -2. To find nitrogen, N, in this neutral molecule, oxidation number of N+2, -2, equals 0, therefore N. 4 is equal to 0, therefore N equals +4. H2O. Hydrogen, H, remains +1 and oxygen, O, remains -2. Compare the initial and final oxidation states to identify the redox behavior. Copper, Cu, increases in oxidation number from 0 gives +2, meaning it loses electrons and is oxidized. Some nitrogen, N, atoms decrease in oxidation number from +5 in number 3 to the power negative, gives +4 in number 2, meaning they gain electrons and are reduced. Hydrogen, H, remains at +1 on both sides of the equation and is not reduced. Conclude the correct option because there is a transfer of electrons where Cu is oxidized and the nitrogen atom in number 3 to the power negative is reduced. This is a redox reaction. This directly corresponds to option D. The correct answer is option D. It is a redox reaction because Cu is oxidized and the nitrogen atom in NO3- is reduced.